Welcome to our first seminar of the spring semester. It's a special seminar. We'd like to welcome John Hall back again. For those of you who don't know John, he got his PhD from Lamont and then worked for 35 years with the Geological Survey of Israel. He spent a lot of time working in the Arctic. He's been on a lot of the sea cruises. His PhD work was also on that, and now he's doing hovercraft work. So he's going to tell us the continuation of the hovercraft work today. So.
Good morning, Nautilus Live Nation. Unaccustomed as I am to speak publicly, since last summer it's a lot easier. It's great to be back, and since I gave my last lecture here last May, we have had another summer up in the Arctic, and when I say we, I should say that I go up at the beginning of every summer and spend 10 to 20 days in Svalbard or Spitsbergen, getting the hovercraft ready with Yngve Kristoffersen, and then he goes up on the ice. He is 2 years younger than I am, and therefore much sprier. And also, having been born in Alta, Norway, he is much more used to the Arctic climes. I myself only have about 15 months of my life on the ice. In any case, I wanted to start off with a misadventure. This is just a picture from the first time that during a sleeping cycle on board the hovercraft, they suddenly discovered that a pressure ridge was in the making, very close to them, and then the ice pulled apart, so there's gear scattered all over the place. But anyway, to get started, this is the logo that we have for what we call the Blodgett Hall Polar Present. Blodgett is my grandfather who made chewing gum, and it was very good to make chewing gum during World War II. With 16 million people in uniform and K rations and C rations having equal quantities of cigarettes as well as chewing gum. And so if you've chewed chiclets, all I can say is I thank you. The hydrographic world thanks you, and that's where it's from. Anyway, the Sabvabaa is a name. Originally, my sister had suggested that because we had two Norwegian PhD candidates, females, who were going to be our first crew, that the name of the hovercraft be Chiclet with a K. Unfortunately, fortunately, Naya Mikkelsen, who is very active in Greenland with the Danish Geological Survey and the Geological Survey of Greenland, said that no, it has to be a name, Inupiaq name, Eskimo name. And so we went through the Inupiaq dictionary until we found the word Sabvabaa, which means flows swiftly over it. And this was the closest thing we could find. For me as an Israeli, it is also important that this is very, very close to the Israeli word Sabvabaa, which basically is the word for awesome as well as neat, or cool, or all of the above. Anyway, I want to introduce the most of the brains and most of the bronze of this, and that's Professor Yngve Kristoffersen, who followed me at Lamont. He has been at the University of Oslo, Tromsø, and now Bergen. He was appointed by the king, and he is one of the 3 or 4 Norwegians who's active in the Central Arctic. The Norwegians seem to have forgotten the whole history of Nansen and Amundsen and others who worked in the Arctic. We are hoping that this, as a Norwegian enterprise, sooner or later will maybe grab the interest and attention of Norway. But in the meantime, we sort of work underneath the radar. Yngve was the one who came up with the idea, and Yngve is the one who is operating there. And as you will see, Yngve is the one who has basically built and patented some of the things that we are using. We have more or less the capability of Columbia's research vessel Vima in the 1960s, but it's designed for being operated on something which basically is an airplane. To start off the year, Yngve was down in the Numair station in Antarctica, trying to close off his connection with Antarctic work. Polar people like to work in Antarctica in our winter, and they like to work in the Arctic in our summer, and it's a good way of switching back and forth. And what he was doing was using a crapped out old Wyoming vibrator that he had 3 of these in his yard that Bergen was using, and they put those on skis, and one of them was shipped down to Antarctica, and they've discovered that you can make very good seismics on the ice shelves there by using a towed vibrator. Yngve also has a workshop at home, and this is dredge number 2 and dredge number 3 that he's made. I can stand and hold both dredges under my arms. They're not like the usual dredges that require a very strong crane to pick up. Everything on the hovercraft operates off of diesel fuel, and most of the power is hydraulic, produced by a hydraulic pump underneath. And so in addition, last summer was this hydraulic chainsaw, 90-centimeter blade, which we use for, as you'll see, cutting through ice or raising blocks or what have you. A new thing also was instead of trying to use a wind generator or photoelectric cells spread out on the ice, we have gone over to these methanol fuel cells. This one here, which costs about $4,000, can produce in one day 2,160 watt-hours. And every 900 watt-hours amounts to about 1 liter of methanol. On the right-hand side, there was a rubber thing that we tried. One of our problems is on snow and ice, we do not have very good directional control. It's all by the rudder behind our 2-meter diameter prop. And so, our sort of a rubber bib was made like a baby has, which would go down underneath the front, and we would try to gain some steerability. This did not work very well this summer, and Yngve tells me, as of 2 days ago from Neumayer Base again, that he's on his way home and he's got all sorts of ideas for a new thing to try out. Also, the dream of the old spar echo sounding buoy. All kinds of buoys have been made in history, but there's never been one with an echo sounder that we know of. And Yngve started out with the construction of 2 seismic buoys, which are considerably simpler than an echo sounder buoy. And the company CMR Research in Bergen was the one that was mating a capacitor bank fired sparker together with a GPS and iridium telephone in order to collect seismic data and send it through as a short burst message through the iridium system back to Bergen, so that we could put a buoy in and collect seismic profiles during the wintertime, during the summertime. And the nice thing about the hovercraft is that it's very easy to set out a buoy, unlike the Ely, where it's a very time-consuming matter. And beyond that, of course, if we're out there, we have the capability of going back and changing batteries or refueling it with methanol. So anyway, here's a SciQuest EchoBox, which is finally what we've decided to use, because one that was developed for $500,000 of NSF money never worked. So continuing on, here's David Petty from CMR Research, who's checking out with a laptop how various things were working on Bergen. Also, last summer we brought up the 6-channel 60-meter streamer, which was bought by CCOM. And Jordan and Emily, I want you to note very carefully that the sticker has been put on the equipment, and anybody using it and looking at it will know the University of New Hampshire is represented. I should point out also that the University of New Hampshire was the channel via which we purchased against reducing taxes for our chirp system, which is 1/4 of the capability of the Ely. It's 4 elements instead of 16. And beyond that, our 12 kilocycle echo sounder plus 200 kilocycles, which is good down to about 5,000 meters. So continuing on, I was asked today if I could show some glacier pictures. And when you go to Svalbard, you fly to the northern end of Norway, and then you leap over about 700 kilometers of sea, pass over Bear Island, and then the next thing you know, all you see is glaciers. So here are some of the glaciers. Below are cold beds, and I should point out that the major town in Svalbard is Longyearbyen. It means Longyear town, and it was named after Mr. Longyear from Boston, who started a coal mining activity up there more than 1 century ago. So here you have these coal beds outcropping. There are a lot of glacial valleys there that you see as you fly along. Other places where here in June there are no snow, but very expensive mud flats. And as I'll show you later, for the first time last summer, we made a rental out to a group at the University Center in Svalbard to take the hovercraft along with one of our people and actually do investigations on these mud flats. And if you are on the mud flats and the water comes up, or if you're on the mud flats and the mud is deep, you're screwed. And with the hovercraft, as you'll see, it's excellent for going around on things that you just plain can't walk on. So continuing on, we're finally coming in for a landing at Longyearbyen, and the hovercraft is right out here. We've been trying for 3 years to get a plot of land on which we could make a iron skeleton building with a fabric cover, so that in the wintertime it will be protected. And in the meantime, well, here's just a picture of Longyearbyen. The runway or the airport we were coming into is right here, and the hovercraft is down here. Here's the main town, and this is looking up that canyon. And the town itself, population is 2,000. UNIS, or the University Center in Svalbard, has 300 students, and they're very proud of the fact it's the only university on Earth that the students, the first thing they learn is how to shoot a bear. The second thing is how not to have to shoot a bear. And the third thing is they take them out in the Zodiac and throw them overboard in a survival suit. And they see that in water that can be down to -2 centigrade, they're perfectly capable of staying afloat and alive. So, okay, going on. Here's the way the Sabvabaa survives the wintertime. We put pallets all around it and cardboard up against the windows. This is snow covered for most of the winter. When we get up there, it takes several days, and last summer, 1,000 liters of boiling water to finally remove the ice and things from the skirts and get it so we could get it going. My job often was just inside working on the computers. We have one bench on the side with many outlets for 6 and 12 volts, so that the laptops that are used can be interconnected through a gigabit LAN and connect to various pieces of equipment. Here I am working on the guts of the provisional breadboarded bathymetric buoy. We originally thought that these buoys would be costing about $3,000, $4,000, operating for several years, and at 12 kilocycles be capable of reaching 4,000 meters. It now turns out that the guts of these, in lots of 100, would probably be about $4,500 from SciQuest, which now has an Echo Box that costs between $15,000 and $25,000. If they took out all the EEPROMs and other things like that, which are connected with the guts plus the power supplies, we could make probably a buoy that would be costing $6,000 or $7,000. And the idea there is being able to put it in and let them operate, and these would supply calibration information for the satellite altimetry. If put in amongst the icebergs in Antarctica, in several years they would go around Antarctica, and of course within the Arctic we could put them out, service them, and I had one paper in Hydro International showing that we could perhaps, back in the old figures for what a buoy was, be collecting bathymetry for something on the order of under $1 per kilometer. Well, anyway, continuing on. Here I am, Naya Mickelson, who changed our name, came to visit us and see what was going on, and then Ole, who is Ingve's electronic guru, is there. Just briefly, we have two of these reflex Danish stoves, which we can cook on, and which also heat the cabin very well. They have about this much insulation and double glazed windows, and ideally, all you have to do is set down on the ice or the water, and you have your habitation all around you. Here we have a visitor. This is Karen Locke, who is the new head of what's his name? Wegener, the Wegener Institute. Alfred Wegener Institute in Bremerhaven. And Ingve is here, and she is together with, I think, the program manager for the Polar Stern, which actually, the day that I left on the 20th of June, sailed into Longyearbyen. It later tried to do work off Greenland. As a matter of fact, was pushed out because of native resentment against the use of air guns. They thought they were doing totally oil company work, when in fact it was more science. But in any case, here's the ship.
Same thing happened to it in Canada.
Yes. Okay, anyway, Longyearbyen is a wonderful place to visit, and this was my fourth trip, and this time Ingve and I, while waiting for a plane, went down and went through the airship museum that we'd always ignored. And the thing is just absolutely filled with memorabilia related to Amundsen's flight to the pole with the dirigible Nord, as well as all sorts of other Arctic goings on. Okay, an introduction to Svalbard relative to the ice cap. We keep it here in Longyearbyen. Ny-Ålesund, which is the place from which Amundsen went up to the pole with the Nord, is right in here, and it's a scientific community with, I think, 30 different institutes maintaining houses and doing upper atmosphere research and things like that. Svalbard is very interesting in that right here by Longyearbyen, there's an antenna farm operated by Kongsberg, who also makes our multibeams. And this is connected to the Norwegian mainland by a fiber optic line, so that much of the remote sensing coverage that you have over the Arctic Ocean is coming from the antennae, which are here. In any case, here's the northern part of Svalbard. The ice in this area is very fractured. It's slowly moving out with the polar drift. It's breaking up. This is the kind of area that we've been operating on. The more permanent pack, of course, is much further north. Okay, these are the tracks for the 2010, and there was a project this past year with the Norwegian Petroleum Directorate to gather dredges and do seismics over the Yermak Plateau. And these are the tracks of the 3 times that they went up. We maintain a fuel depot down here, and you'll see a picture of that later. But they were up there, and on these steep edges, they were doing dredging. And here are the listings of the various things going on. Of interest here is, together with Christian Haas, who is now from Alberta, we are operating periodically an electromagnetic probe, which is telling us every 2 seconds what the ice thickness is. And this is generating a pulse. The other side of a 4-meter long boom is picking up the reflection with a pi phase shift from the saltwater interface underneath the ice. And there's an acoustic altimeter, which is finding out how high the instrument is above the ice as the hovercraft goes along. And by correcting the geometry there, you can figure out on the fly how thick the ice is. The usual way is somebody going out on the ice using an auger, going through, putting through a yardstick, and then measuring the thickness. Also of interest, the ice cores, which were primarily for graduate students who went out to some oceanography. The previous 2 years, we were bringing a CTD, and we actually have a 160 kilo CTD winch which can be mounted on the forward part of the port wing. And without leaving the vehicle, you can actually put it out under hydraulic power. It moves over, and in so doing, a C-beam CTD, which is here, is then swung out, and down it goes. And as a matter of fact, on the invitation, there's a picture of that making a CTD lowering through a seal's breathing hole. Seismic reflection and drift mode, you can see the figures there. Sediment cores, we tried 2 the first year. The latest results with the sediment core, which is constantly undergoing revision, it's hydrostatically boosted. It weighs 70 kilos with the core tube in, and I can hold it. And what it consists of is the core tube, and after that a cylinder. Cylinder has a piston on it with detents that are holding that. And then further on up, there's an umbrella, which is upside down and held together. And the whole idea is to lower this down. And in our experiments thus far in 250 meters of water with 25 bars pressure on that, when you trigger it, we generated 1.3 tons of push. So over the Alpha Ridge, which is our target, in 2,500 meters of water, we would have 13 tons equivalent of lead on the core. And this is the core that I can hold. Beyond that, you'll notice the rock dredge is successful here, and last summer they had quite a few of them. Here are the number of trips that were made. In these 2 years, we were going up, taking 2 Norwegian high school students at a time, and introducing them to a week of doing glaciological, oceanographic, and geophysical measurements. And the idea there was a program which was trying to foster a coming generation that would think in terms of Arctic research with the hovercraft and not necessarily with an icebreaker, which Norway does not have. So, total mileage, you can see here, we've almost come up to 10,000 nautical miles north of the Arctic Circle. Every year, the amount of distance over sea ice is going up. This is primarily a function of being able to carry the fuel necessary, because our fuel consumption over the ice is far higher over the kind of ice you'll see than what we considered. This is how far north into the pack we went each time, the longest trips we made. Fuel consumption at economy speed, the sweet speed, the sweet spot, is about 25 knots over the water, and is probably 4 to 6 knots over the ice. Here it is, okay, here are the figures over water with full payload. And the Griffin 2000 TD, which is our model of hovercraft, is rated at 2,200 kilogram load. And we have been consistently carrying an additional ton. We don't know whether or not we can even further raise this. But this is the very interesting figure there, and thus far the company has not said, stop doing that. Okay, so continuing on. Here it is in its ice environment, and the hovercraft itself, empty, weighs about 5 tons. When we're carrying our full payload, it's slightly over 8 tons. It's equipped with a Furuno radar here with a complete Furuno navigating system with waypoints and being able to set the radar so that if we're drifting off our position, it will scream bloody murder. And we have the capability of carrying an extra 1,500 liters in addition to the 480 that we have in fore and aft tanks, which are used for the trim. And of course, to get up to speed over water, it's very important that we do have the trim. In the sea trials we got up over 43 knots. I, of course, with my large bulk, had to be next to the firewall forward of the engine. As soon as I heard 43 knots, I went forward, and we were doing about 24 knots. In any case, whoop, wait a minute. Okay. We carry equipment. Equipment can be, for instance, with the CTD winch, this can be attached here. Also on the sides, we have the drums for the winch system that we have. Our winch, as you'll see later, is capable of 3,500 meters of Kevlar lined with a more than 2-ton braking strength. Important thing about the Kevlar is it's neutrally buoyant, so that no matter how much rope we have down there, we're not getting close to our braking strength just by hanging onto it. Also, there is a night vision camera right here, which we've never had occasion to use because we've used it only during daylight period. Should point out all the time that we've been operating, the sun has just been going around and around and around because long near Vienna's at 78 north. Here is the Here is the ideal type environment where everything is very flat. Everything is very flat, and the water surfaces are very flat. As you'll see later, this does not always happen. Ideally, we can put it down. We have a solar cell that we can put up, which, if the sun is looking directly at it, and if there are no clouds, we can generate about 180 watts. Now, this we put in when we were thinking very green. I suspect sooner or later we'll take this off, and instead, when the Chinese come up with a roll-up 100 square meter 10 by 10 tarpaulin that we can lay out in the ice, this will make a fantastic generator for us no matter what the clouds are doing. For you with the Coast Guard bent, we are required to carry all the EPR, IRBs, and rafts, and all kinds of other things. And of course, if we're going at high speed, we have a rotating yellow light which has to be going, so the bears and the seals are at high speed. Okay, this is more of what the ice looks like, but again, between the open water and the flat places, we can maneuver around. The hover height of the hovercraft is 73 centimeters. We can count pretty much, if the trim is right, on 60 centimeters. We don't want to go flying over things which might rip a hole in the hull. I should point out that there's about 160% redundant buoyancy and a large number of buoyant chambers that are built into the hull, and it can survive quite well with something like a 2-liter gashing. So going on, here it is with a beautiful rainbow over it. In this picture, it's worthwhile noting a diving bottle that we have here, and covered behind it is a hydraulic air compressor capable of producing 190 bars. And this is operated either by a hydraulic pump, which is on our 440 horse Dutz diesel engine, which is a standard engine used throughout Europe. Lots of parts are available very close by. We also, on the other side, sometimes carry a 6 kVA generator, which has a built-in hydraulic generator, hydraulic pump. And this can also be used for powering the air gun system we have. Here is one of the 1,000-meter drums that we use for the winch. And assorted other equipment. This is the capacitor bank. It's a 65-kilo capacitor bank that generates 7,000 joules for the sparker of the seismic pool. Snowstorms also occur in June, and this was probably sometime in July that they had one period with snow coming in. When it's sitting there, you close down the gull-wing doors, you start up the reflex heaters, and it's quite enjoyable. Inside, when you're operating, you have 2 bunks that come down from the after firewall. Then there are settees on the side that, depending upon where you put a aluminum pipe, if you put it down on one side and the other part up, you have a settee. If you put the 2 of them at the same level, then you have bunks that are 2 meters long. Looking forward, here's the case. There's a kitchenette up here. We do not have a refrigerator. This is out on the wing. We do have a microwave together with a hot plate. And the funny thing is that the battery bank that we have is very good for science if everything's shut down. But the power that's drawn by the microwave is such that we usually start up 440 horse engine for 5 minutes in order to move dinner. And forward, there are 2 seats for the pilot and co-pilot. I should point out that when you're going fast or even over the ice, the motion is not really like this. What you have is this all the time. And when you're really pounding on waves that are a meter and a half height, you find that it's very hard to breathe because your diaphragm is under compression. Okay, disasters. This was the case where there's a whiteout condition more or less here. You don't really see the horizon as you're going along. You don't know that there's wells and swales and drifting sand, snow. And if you come up on one of these, and all of a sudden your bottom hits, the skirts are hanging down there, you're not maintaining your bubble, and you're high and dry. So in this case, the next thing to do, here it is from the side, is then to get out and with a chainsaw or gathering blocks from pressure ridges to start building up a wall there in order to get air down underneath you and then slide off of it. The alternative, of course, is a small electric winch that we have, which has been used time and again. And we have fore and aft a place that you can quickly hook in, plug in with that, and then there's a rub rail so that it will swing around through a very wide arc. And then you auger a hole down, put a pipe into it, and you can pull yourself off just straight up without any finesse. Here is Ingve next to the wall of these building. The skirt basically is a permanent skirt that comes down so far, and then underneath there are 100 sections this wide, diamond shaped more or less, which make contact with the ground, and they have to be changed about every 35,000 miles, just like a set of tires. And here it is after they pulled it off, or after this may be at the time of the pressure ridge formed. This was after there was this collision, then it broke apart, and in this case, they have over here the box for the buoy, and I believe, okay, you can see wires here, there, and young. Looks a bit like the Endurance before she sank. Oh yes, and right over here is the spark array, which was originally bought for the buoy. This was a 15,000 pound expense array. I will use instead the kind that I used for my seismic profiler in T3, which is about $20 worth of brass and DR tape and all kinds of things like that to make up a single electrode. Okay, so continuing along, here's another picture of that, and gradually they straighten stuff out. Here is a picture of our refueling station in the northern part, our fuel depot. We're allowed to set this out in the spring, and then we have to bring everything back at the end of the summer and leave it pristine. Svalbard is such that it's basically a national park, and it's in charge of a governor who basically is a dictator. And if you land anywhere on the beach, you have to notify the governor where you are and basically get permission for doing so. And we had one very close call in that we missed one of the usual call-ins through the Iridium system. And this was a time when we were going to be coming back from the ice, some 100+ kilometers across open water to Svalbard itself. And the governor fired up his 14-passenger helicopter and headed out for search and rescue. And finally we got through, and we have to maintain a $50,000 bank balance for such eventualities. And mercifully, the governor said, okay, this would be a technical exercise. And thereafter we said, look, if you don't hear from us, don't worry. By and large, hovercraft don't sink. When I got insurance for this thing. I had the secretary of the British Hydrographic, British Hovercraft Association write up a report on the 1,200 hovercraft that he knows about. And we came up with only 6 fatalities. And of these, 3 were on those that crossed the channel. There were 12 of them. They made 44,000 trips each. And during one storm, they ran into a concrete abutment next to their landing area, and 3 people were killed. And we know of only one that sank, and this turned turtle, and there were people down inside. Firemen opened up the hull, and it went down. So anyway, they're very safe, and of course, as far as collisions and things like that, as soon as you start the engine, all of a sudden you've got an extra meter on either side of the skirt. And as you'll see later, if bears get close, the main thing you do is just start the engine. It scares them, and if actually they're trying to get up on the wing, this will just send them over. Okay, also in the northern part, you can go and visit. These were some hunters, and these are caribou that have been skinned and are being air dried. Okay, bears. Monahan, this is for you. Okay, this is a girl's hand relative to bear paw. Here is the bear coming. So they, by and large, whenever there's water, if they can't leave it, they swim. And marine mammals are capable of swimming over 100 kilometers. Unfortunately, the ice edge north of Alaska is several hundred kilometers out, so we're beginning to see, the icebreaker people are beginning to see dead bears from the ground. They are not like your land bears. They have much stronger bone structure, and they're definitely marine mammals. There he is, sniffing at various things. Then getting closer. These are from different occasions. I do want to point out the ice conditions here. A bear would have a hard time. Perhaps he could hop from there to there, but in stuff like this, he basically has to swim through crushed ice. It's like what you have in a margarita.
That's why I have double pay.
Okay.
I assume that's protective glass?
Forward it's glass. The window was open.
Oh.
I mean,
Lunch?
they don't stink. We don't stink. Okay, here's Ingve working with the laptop, making sure that the iridium system here is transferring the pigs that are coming out of our 3.5 kilocycle transducer. And the thought is, if we are going to have to pay so much more for a well-known system, we might as well have the capability from land of saying, we're in an interesting area, let's switch over to chirp mode, and we will pay far more for the iridium transfer instead of an XYZ. It will be an X, Y, and a time series of Z's. Here is our 12 kilocycle, 200 kilocycle system. And originally we thought we were going to tow that. Sooner or later it may very well be that we will take a transducer and we will put it on a pole underneath the wing with the capability of lowering it down while we are on hover. That's 40% of the power, but not with the 60%, which will allow you to fly. So here's the spark array, which I hope is going to be replaced sooner or later. Here's a 20 cubic inch air gun, which we use for air gun seismics. You've already seen the streamer that we have. And here is one of those dredges with the teeth and everything. The way in which the winch works is to have a capstan, which is doing all the pulling. And of course, you notice that it's sort of got a lead in through the edge of the ice flow. The ice flow is sort of like this, so you want to cut in so you have the full thickness underneath the winch itself. Here are the hydraulic controls for that. And whatever's coming out is going and onto a drum which also has a hydraulic feed, but not under great tension. And that's it. And then here are some of the rocks that were gotten on with the dredge holes. Here's the system, again, with the hydraulics on this drum, and as soon as you get through with 1,000 meters, you make a connection, and then you do the next 1,000. So each one of these can be picked up by a person and put on the wing. Here it is again, and I don't know whether they had just lost one of these a year ago or what, but in this case, there's quite a wuzzle that's there. And right off that, I mean, these are what the ice conditions are like, and we're sitting on a flow which is probably 3 times the size of the hovercraft. Wait a minute. Also, here is the pipe, which has been put into an auger hole, and that is your anchor for the whole dredge. Here's ink bag, open water next to it. I am planning at some point to put a multi-beam on it. Kongsberg told me several years ago at a FEMI meeting that they would give me a 40% discount. Since this is a Norwegian project and it might bring some sort of honor to the Norwegian community, I have not followed up on this. The idea would be to put in EM 710 with the absolute minimum box, minimum cards, and the transducers, which are very light, 15 by 40 centimeters, make a Mills cross with some sort of backing, acoustic backing as well as flotation on that. And then inside the housing that has a little motor which allows it to turn 180 degrees. And on top of that are MRU, which would be a bubble. So you just sort of adjust it by not a wide lead like this, but instead one that has very calm water. Put it down in that, and every few hours you rotate it. And do exactly what Martin Jacobson's been doing with the Odin, with the, what is it, EM120 that he has. Okay, so going on, here's some of the rocks that were obtained. The rocks already from last summer and this summer have gone to somebody at the University of Bergen, a Japanese fellow who is very cognizant of what's going on. And presumably papers will come out on that. Papers have also come out on the CTV work that we've done. Another picture, artistic, what the much of the Arctic is like today. You can't, I wouldn't be happy camping on it. I don't mind with hovercraft because no matter what happens, you've got something underneath you. More visitation. Here it is up on the beach in northern Svalbard. Here's a glacier picture with a glacier in the background. You have to remember that if these things calve, you might have a small tsunami wave that comes. Okay, going to the time that we rented it last summer, there were some people who wanted to look at soil patinas or do dry land coring or don't know what. In any case, we are environmentally friendly. The loading of the hovercraft in flight is the same as a seagull on one leg, and that's from the National Science Foundation. And if you look here, all of a sudden you notice that, people have been walking around.
That's a great blackback gull, or is that a ringbill? Come on. A gull? Or
it's a standard NSF seagull. This is Jürgen, who was one of the people who works in logistics at UNIS. He was the pilot for this trip, and you know, the kind of mud flats that on something like that you can move at 25 or 30 knots. No problem. The interesting thing is when we did our sea trial, when there are waterfowl around and stuff like that, they don't want to be in front of the hovercraft, but they just move sideways. They don't all suddenly fly. And of course, all these things which are constantly diving in the fjords, they just sort of go down, and I don't know. As we go along, we're leaving sort of a thin layer of bubbles, which would interfere with echo sounding, I believe, unless we get below that bubble layer. But in any case, it is
very, very benign, and much less noise than a helicopter. Okay, so that concludes the part related to what the hovercraft was doing last summer. I just want to point out, why the hell are we doing the hovercraft? And that is, our target is the area of the Alpha Ridge on which a seismic profiler that I built but which I did not study. In other words, I went off to Israel in 1970. The ice station T3, or Fletcher's Ice Island, continued to operate through September of 1974. And it was only in 2003 when I was here that Ingve invited me to Bergen. Please bring the seismic records with you. We began looking through them, and lo and behold, we discovered that the last 4 years of drift over the Alpha Ridge, we were missing up to 500 meters of the blanket of sediments which cover almost everything in the Arctic. The almost is the Geological Ridge, of course, which is now spread. And this suddenly gave us the explanation why 4 of the many cores that have been taken by the ice stations were aged between 40 and 70 million years, because you have to keep in mind that the sedimentation rate in the Arctic from ice-rafted debris is about 1 meter per million years. So most of the cores that we took, they were looking for magnetic changes and things like that, and doing the paleontology, but most of it's stuff that ice picked up on the beach and dumped out into the basin, or which came out in very fine particles from the rivers in Siberia. And the interesting thing was, okay, how can we get back to that area? Because that area is the area of multi-year ice, which was up to 6 meters thick when I was there in the 60s. And it's about 4 meters thick up until 2007, when this reversal of the Atlantic Oscillation finally caused a significant part of the multi-year ice to go out. But we know that even atomic breakers can't go in there from the attempt of the 50 Days of Victory and the Odin to do survey work for the Danes for UNCLOS north of Greenland. And the 50 Days of Victory bunged up its screw and had to go back. It was on warranty, it was a brand new atomic icebreaker from Russia. And the Odin very nearly lost all their seismic equipment. The ice was just much too thick. And they had horrendous times for using helicopters trying to get the streamer back. So anyway, last summer, Larry did not go out in the Healy, but Larry did come to me in the Eastern Mediterranean. So I signed on for 32 days on Bob Ballard's ship, the Nautilus, and it was a mind-blowing experience. So after 48 years of, to complete the business of what we believe is on the Alpha Ridge, an asteroid came in and blew the upper sediment off. Where it went, nobody knows, but we see this over an area of 200 by 600 kilometers. 2 papers have been written on this so far, and without much reverberation from what we published. But this was enough for us to put approximately $2 million so far into the hovercraft effort. And what our plan is to use the seismic equipment that we have to get out to the Alpha Ridge, preferably riding piggyback on an icebreaker, which hopefully would leave us with up to 20 tons of fuel to stay for 6 months to a year as a mobile station going around, trying to find out where we are deepest in the section, and then stick in the core. And keep the cores. The cores aren't that big. It's not that much weight. Presumably we would have aerial resupply of food and perhaps personnel. So that's the long-term plan. We were hoping to do this next summer, and finally we decided we need 1 more summer of testing gear. The long-term thing is the plan for the Aurora Borealis, which would be an ice-breaking drill ship, which the European community would like to build if they can get together the 700 million euro. And Jorn Tita, who was former head of Geomar, and then after that the Alfred Wegener Institute, is head of that, and he wants very much to have the Sabvabaa on board. This would give us 2 helicopters, it would give us machine shops, probably close to 20 million liters of fuel to use, and hot showers, good food, and the ability to go out for 2 or 3 weeks at a time and just probe for new sites for them to, for the safety committee, as well as knowing just exactly what some of the best places to try to get in here. So, okay, going over to Ballard. Ballard has built 2 ships. You know all about the Okeanos Explorer, and I suspect that you've already had feedback on what Nikki and Larry and others saw last summer. But here's Bob with yours truly, and the vehicles that were involved is the Argus, which has a side scan right here. Argus is at the end of up to 4,000 meters of fiber optic cable. It is isolating the Hercules here, which is much heavier, from the motion of the ship. Also, it is providing camera coverage of what Hercules is doing down below. The modus operandi, by and large, is to come to an area, and if you're looking for wrecks or things like that, you'll first do a survey with the side scan sonar. After that, the tether will be hooked to Argus, and then the 2 of them will be launched. And I should point out that Ballard, of course, was very involved in the early manned penetration of the oceans. He saw the light as far as using ROVs. When it was whole, they finally decided that a scientist would be going down too. And so a very senior scientist was selected to go down with him. And instead of kneeling at the little tiny porthole and keeping his bladder under control for 9 hours, Ballard discovered that this guy was always looking over Ballard's shoulder at a little tiny TV screen he had and a video camera that he had mounted outside. And they figured, what the hell are we doing down here, freezing, taking hours to come, go down, hours to come up? If everything, the most interesting thing is a video camera. So after that, he began concentrating on this. Now, the Hercules has a $200,000 camera here, which can go from an ant's eyebrow to the full view. And this has a video operator up on the ship who's making sure that the color balance and everything is fine. It also has about 4,000 watts of lighting here, so it can light up a large area. An aquarium on top so that they have a vacuum cleaner that you can slurp things that the manipulator arm would crush, as well as a manipulator arm and boxes around with various names and numbers so you don't get things mixed up that the manipulator is put in, as well as a bunch of cores also, which are anything up to about this long, where with about 80 pounds of thrust, they are capable of sticking it into something. After that, Hercules moves. So anyway, going on, here was our target for Larry's 2-week cruise. This was Aristosthenes seamount that I first made a map of in 1978. It's south of Cyprus, and it's a seamount that basically has gotten jammed as it tries to subduct down underneath Cyprus. So those were the lines that Larry did, and of course he absolutely wowed everybody with player mounts. And his cup of tea. And acting as a robe operator, here we have the side scan results here, the search sonar, of course, Larry's computer. Here again, Larry overseeing. The system there consists of a talker, 2 data operators who are gathering information on targets that are found, the chief scientist, of course, the video person, 2 ROV operators. There's a teacher at sea who's communicating with the 4.7 million kids who are in almost 5,000 boys and girls schools of America. And Bob's target audience basically is kids under the 8th grade. His feeling is that by the 8th grade, somebody knows whether or not they want to be a scientist or not. And the thing that really rankles him is that the exploration of the heavens under NASA has 1,700 times the budget of NOAA's exploration of the oceans. And so, in his own way, at a cost of $7 to $8 million a year, of which $3 million he has to go out getting by lecturing, he is hoping to slowly push the interest over to the thing that catches our interest. Okay, this is what one of what Bob calls those mega wow minutes, when all of a sudden the camera swings around to something and all you hear is whoa. These were tube worms on the side of Aristosely Seamount, which is a volcano which we published on from Russian work in one of the books I put out. If you want a copy of that book, go see Shahak. He has 20 of them on the shelf. Later work pretty much showed that it had to be some sort of volcano far down, and there were 4 of those, one under Mount Carmel, another one about 70 kilometers off Israel, the one south of Cyprus, and the biggest of all, which has no superficial representation, is a little bit further to the west, and it has a huge magnetic and gravity anomaly. But in any case, on top of that grew corals, and when the Mediterranean was dry some 5 million years ago, and that would have been a seamount sticking up 2.5, or a mountain sticking up 2.5 kilometers. Presumably a lot of rain on the top. The rain has made sinkholes, as well as lots of karst, and these things are growing in the cavities that you have. Some sort of nutrients are coming out. This is going to be a target for biologists in the future, but putting in a temperature probe with the manipulator arm, we found that there was a temperature anomaly. It was about 0.2 degrees centigrade. It has nothing to do with a hot spot. This is not the first time tube worms have been seen in the eastern Mediterranean. They are found also on the mud diapirs, which are off the Nile. Here's another picture of those. This is a blow-up of just pictures I took of the 46-inch screens. I was a talker. I have never done this before. I got all sorts of kudos from what I was doing, and much of it was just sort of going along stream of consciousness, and every half hour or hour updating what we were doing, what the plan of the day, how the plan is changing, what we wanted to do, and what the internet site says, how that's changed. I should point out that I donated $25,000 to Bob Ballard to build one of his centers at the University of Haifa to try to give a push to the marine geophysical effort there. And that was manned during the month that we were operating. And of course, they could see everything that was going on from the ROVs and the various cameras that we had inside the control van. And the interesting thing was everything that we were seeing was coming up 4,000 meters of fiber optic cable, shooting out to a geospatial satellite that was 22,000 kilometers out. It was being vectored over to Andover, Massachusetts, and a receiving antenna there, going by landline to the University of Rhode Island, where the webmaster was. Webmaster was putting it on the web. It then was crossing the Atlantic by fiber optic, going down the Mediterranean, coming into Israel, and 3 seconds went by. So in other words, they would tell us just exactly what point the clock, which is up above, giving us GMT, changed to an even minute. And 3 seconds were what was required for that. Absolutely amazing. And after just 48 years of bombarding the bottom with explosive sound and boomers and sparkers and air guns, and then doing multibeam at various frequencies, and finally side-scan sonar at very high frequencies, just to see what the mud on the seafloor is, and what's living in it, and what's churning it up, the divots of diving rays that are searching out things, eating that. One of the weirdest moments was Hercules going along, and all of a sudden, like the Roadrunner and Wile E. Coyote, there was the dust trail that they kick up as they go. All of a sudden, from underneath Hercules, this sped out ahead of us in the camera's view, and then suddenly, 2 dust clouds going up, presumably 2 rays, one after the other, one on top of the other, and it just decided, okay, Splitsville. Just absolutely amazing. So I heartily recommend it to you. they are going to be operating in the Mediterranean in the near future. He wants very much to get down in the Red Sea, and the problem with the Red Sea is the insurance company says he's going to have to up his $17,000 a day rate, add another $9,000 to it for protection. So, anyway, okay, the title also said what we've been doing with Multibeam, and here is the Eastern Mediterranean, and where we were working with the Nautilus. This is the map that I made in 1978. This is the amount of Multibeam which has been done by the French over a period of probably not more than 5 months. This is the amount of work that has been done off Israel in 10 years. I love shallow water. Anyway, the whole idea was, okay, let's go out with a ELAC, don't cringe, an ELAC L3 CB 3050, which is a multiple pane 50 kilohertz system, which had never been used in deep water before. They're being bought up like cakes by Asian navies as well as the Indian Pakistani Navy, primarily for using the water column data that you get the submarines or mines. In any case, we were doing a surveys out to 1,600 meters, and here's the system here. Here's the leg that we put on the 65-ton aluminum ship that Tel Aviv University uses for biology, and basically we did this area here, some 8,000 square kilometers in 5 lakes. And here's part of it attached to the work that was done with my Simrad 1002. This is Haifa. Here's the border with Lebanon. And of course, Israel continues to move down like that. Here's the crew of various people who were involved in that, and yours truly. Also, since the last time I was here, we did a survey of a NAR, N-A-A-R, which is a volcanic blowout lake in Golan Heights. I declared when I started this that I was going to do all the water bodies in and around Israel. We have finished with the northern Gulf of Aqaba, and we have done the Sea of Galilee. And I believe Hadar has most of these maps on the wall. He certainly got them all. We have done about 70% of our Mediterranean offshore, and we hope to finish that in the next year. And this NAR was there, and so in one day it was mapped with a Klein 3900, as well as a CZ magnetometer and a boomer, which was, no, a sparker, which was being kept encased in the saltwater envelope. So here's the research vessel. Here are depth changes since the previous survey. Here were the survey tracks during that one day. And a geophysical vessel, but micro size. Here's the sparker here. One other thing which is going on and which has recently been completed is the Intercontinental Drilling Program. And finally, after years and years, $2.3 million was raised. And during the months of November and December, the barge was set up. This is the ship that we did our survey in the Dead Sea. And my student, Ronnie Sadeh, will be coming, Hadar's brother, will be coming here next week to meet with Jonathan Baudouin to try to straighten out the problem that we have in the Dead Sea, where the sound speed is 1,820 meters per second. And we used the VLAC system that was tweaked with the, fooled into thinking that between the two transducers it was 38 or 30 degrees instead of 38 degrees. That was a correction for about 1,750 meters per second. Jonathan is going to try to, or has been working to unscramble that change they made and bring it up to the 1,820 that we're seeing. And as soon as Ronnie finishes the mapping of the Dead Sea, then he'll be able to finish his PhD, which is everything along the rift. So here's the ship which delivers out there, which we use for our Multibeam survey. Here's the As this moves around, this was operating in a crater lake in frozen Siberia. After that, it did Lake Van in Turkey, and then it moved to us. It comes as sort of a circus caravan of 35 different containers. The containers are made so I think it's 12 of them can lock together to make a drilling raft. And they're partially ballasted so that it becomes more stable than a 12-ton drill rig is put on it. And here's the system that has a number of anchor winches on the corners. The main problem they've been having is that in the wintertime there are storms on the Dead Sea. The water density is 1.35. The waves are like hammers when they hit, and the currents. Along the rift you have very strong winds from time to time. And it has been not really dragging its anchors so much as moving. They're in 300 meters of this salt water. With the result that they have been bending the core pipe, and recovery has been between 15 and 70%. The Dead Sea gives you a chance of looking at the different types of materials that are being dropped, basically get a climate picture year by year by year by year. They did a number of holes down to about 450 meters depth, and they're going to try to put them together to work out some sort of a climate thing. Of course, when they get back, 3,500 years, there should be the evidence of Sodom and Gomorrah as you have in the Bible. Here's another picture of the rig with the mountains of Jordan in the background, and yours truly there, actually, looking at the drill pipe. And thank you very much for your attention. Are there any questions? I would like to thank our audio-visual team here, who has been taking care of everything. Nikki was with me on the icebreaker, with me on the Nautilus, and I was hoping would be with us on the Mediterranean Explorer, but she wanted to finish her thesis. And of course, Will Fessenden, who is a long-lost uncle, grandfather, whatever, of course, developed AM radio and the first Venmo. Questions? Silence. Is this guy out of his mind?
No. John, the last question is, what do they think it is now? Is it a oceanic crust or is it something else?
It's a volcano with all kinds of coral on top of it, and as far as what type of crust, they haven't gone into that. The presumption is if it's a volcano, it must be oceanic. Okay? The Eastern Mediterranean, for those of you who aren't used to it, is quite unusual. If you go down about 5 kilometers, you're in the Jurassic. We have 14 kilometers of sediment there. And as you look at the way the continents move around, off the Levant and North African coast, you have a sea, the Tethys, which was there for an awfully long time. And what is there, we don't know, and what is very clear is that we're not going to be able to know because in order to get down to the basement rocks, we would have to drill something in the order of, 2 kilometers more than the deepest hole that took the Russians 20 years to do on the Kola Peninsula. What I can say is that it is in the last year and a half that the gas fields which we knew of off of Egypt as well as Gaza now have shown that the 3 gas strikes that we've had offshore are the largest gas fields discovered thus far in the world. So in the last year, all of a sudden, Israel has seen that instead of being a country that is quietly buying its fuel, coal, and gas elsewhere in the world, we will be exporting it, and we will certainly, for 30 years or more, have all the energy needs we need for desalinization as well as energy production.
Well, actually, I do have one question. We're actually broadcasting this. So Sam is listening in, Sam Greenaway, and he wants to know, how are the transmission issues?
Tell to send Sam my love.
How are the transmission issues working out with the hovercraft?
Transmission.
Yes.
It does not have a transmission. The problem that Sam knows about is that on our first summer's operations, just as they got back from the ice edge, the clutch, which was at the, you go from the motor to the lift fan to a clutch, which then allows you to decouple from the propulsion fan. And the clutch gave out, a bearing burned out, and as a result, we had lift, but no off. And as a result, they were able to hop overboard and push it next to the beach and then pile up some logs and use the winch to pull it up on the beach and call the governor and say, we're now on the beach, we have permission, please. And then beyond that, to look around for a ship to charter to bring it back. And there is a ship which is more or less like a landing craft. It has a very large bay plus a crane that can handle at least 5 tons. And we carried the lift straps with us. And as a result, they arranged a $15,000 charter to have the ship which brings equipment and fuel up to the Allison to travel another 150 kilometers or so to northern Svalbard. And one of the juiciest pictures that I have is a little tiny micro Zodiac with a putt-putt coming in to pick up the hovercraft. And way offshore is this landing craft thing, bright red for the Arctic. And so as soon as the lift fan lifted up the hovercraft, it slipped off the beach, through a line, and here is the putt-putt carrying the hovercraft with it, which is lifting high. And after that, there was a huge argument. Why is it that a clutch bearing, which should go for at least 33,000 hours at full RPM, why did it crap out after 318 hours? And I told the company, you can argue amongst each other, but we had been putting grease in all the time. There was no. The ideal thing for every grease fitting is that you have an input hole and an output hole, and when you start putting grease in, as soon as you see grease coming out the other side, you know that this thing is lubricated. The clutch went back to Southampton, England, where Griffin is located, and the determination there was that the bearing that was in there had never been lubricated and had no way of being lubricated. So as a result, the clutch was changed. Presumably, we will not have this problem in the future.
John, I had a question about your Dead Sea research.
Yeah.
Trying to get a better climate picture from the various layers. You're looking in the water column for that information, or are we looking?
No. Salt is accumulating year after year after year, and depending upon how much sediment's in there, or how much salt is in there, or the geochemical composition of the salt, the proportion of evaporites and other things like this, you can find out all kinds of things about what the runoff from the Jordan River into the Dead Sea was, and presumably quite a bit about the climate and the temperatures that were pertaining.
Let me ask, does the lack of runoff now flowing into the Dead Sea, will that ultimately affect any of the results that you're going to see, or?
No, because that's been going on since the Jordanians as well as the Israelis began intensive agriculture along the Jordan Valley with drip irrigation, all of which is coming from the Jordan River. And as a result, the Jordan River is now more or less a sewer line leading into the Dead Sea. When we did our multibeam survey in the northern end, and we came up to the Jordan River Canyon, which cuts down, I should point out that the Dead Sea level has been dropping at about 1.20 meters per year since I arrived in 1970. And the level has gone from minus 398 meters when I arrived to its 423 below sea level now. And when you get up in that part, first there is a very strong smell of sulfur, which would have, of course, gone into the Bible with Sodom and Gomorrah and what was happening there. There are sulfur springs that are in very ugly muds that are all along the Jordanian coast there. It's sort of a demilitarized zone and nobody else wants to walk around there because the mud is very deep. But the interesting thing is the water that's coming in, there's just a crackling noise as the mixing is going on between the freshwater sewage, more or less, and the Dead Sea water. And it's fascinating. And also ripples coming off of it. The whole sea is alive there as the mixing process is going on. I mean, basically, the future of Israel as well as Jordan is going to lie in desalinating up to basically millions of cubic meters per year. Any questions on what I talked about? And I spent about 15 years taking the soundings off 1,500 nautical charts. The densest chart has 64,000 soundings written on it. And this was a bay on the Nile Cone. Anyway, what I've been practicing doing actually in the fall while I was on the Nautilus was making a 100-meter grid for the Red Sea for Bob Ballard when he gets down there from Russian mapping. And the thing there is to work with the 30-meter data that we now have on land, and I have left the disk here with the 30-meter data for all the land between 83 north and 83 south, as well as satellite imagery. Will knows about that, and also Agar knows about it, and Colleen knows about it. But anyway, to work out what the shoreline is going to be, where we have land data, and then start taking all the inshore hydrography, even though it's shoal biased, and together with the contours which have been put into this charting, and make a 10th minute grid from it, and fill in the areas out to where the multibeam is. Since there are 46,000 kilometers of shoreline, this should keep me busy when I grow up. If you've been in to look at what JEPCO has nowadays, in the last 6 months, the coverage for the Caspian Sea finally arrived. Instead of being at 21 meters below sea level, now it gets down below 1,000 meters below that. And especially with the file that they have there showing the data sources, there's a tremendous amount of data which went into that. And if you look at what they have for the Mediterranean and for the Red Sea as well as the Black Sea, it's a very small quantity of data. I've asked Dale Shays to generate XYZs from all the Multibeam available from the National Geophysical Data Center, which is an MD system that I'm not familiar with. And he's going to give me that for some areas which existed on that database. And then beyond that, I have literally millions of soundings that I've picked off. And together with the contours, by creating that, you come up with something which is a good basis for change when you have something better. But at least I expect that probably within 5 years, we'll probably have a 10th minute grid, which will be sort of the first step in the wonderful idea of GoMap for the world at 10th minute, which has never been funded. More questions? I should also point out, in my old age, I've been busily trying to get rid of all the crap that I collected. The multibeam, when it finishes, depending upon whether Larry finds out that its serial number is too low or too high, will probably go into the Nautilus. And I had 22 map cabinets, 8 drawers each. The better part of that is going to a map archive that we established at the Oceanographic Institution in Haifa. And with the establishment of a School of Marine Sciences at the University of Haifa that Hadar was going to. They have taken 173 books and journals, so there's a complete, since 1964, the complete AGU, planets as well as, oceans and Earth, together with geophysics, together with, or SEG, together with GSA and the Naval Institute Proceedings and Marine Geodesy and a whole pile of other journals. I had something like 47 subscriptions going because I was the first geophysicist at the Geological Survey, and against all the regulations in Israel, they actually allowed me to work at home for 25 of those years. Without that, I never would have been able to do most of the things that I did, because Geological Survey is located right in the heart of ultra-Orthodox Mea Shearim, which means that from Friday noon until Saturday night, you have no way of getting in there or doing anything. And if you're caught, you're skinned alive. You guys have been awfully patient. This has gone from 1 hour to 40 minutes.
All right, let's thank John again.